In this experiment, I will explore the phenomenon known as capillary adhesion. Capillary adhesion can be represented by figure 1, where h is the height in meniscus and theta is the contact angle. For this experiment, I will focus on finding the height of meniscus. Figure 2 represents a top-down look on one of the plates. Notice the area for the experiment will be the area of the plate, which is length times width. Some important equations to know are shown below. Equation 1 represents the adhesion force. The adhesion force equation will be used to find the height of meniscus, represented by equation 2. I used a spring in the experiment, so the force will equal negative kx, as shown in equation 3. Equation 3 is known as Hooke's law, where k is the spring constant and x is the distance the spring stretched. The materials needed for the experiment are the following: command strips and hooks, a spring, a cutting board, isopropyl alcohol, water, olive oil, ruler, 2 glass slides, and calipers. The procedure for this experiment goes as follows. We will measure the length and width of the glass slides using a set of calipers. Then, we will stick 1 command strip to a cutting board and place 1 glass slide on top of the command strip. Then stick a command strip and hook to the top of the other glass slide. Put 3 drops of liquid across the bottom glass slide. Then place the top slide onto the bottom slide. Make sure that there is enough liquid to completely cover the 2 glass slides. Then hook a spring to the top glass slide. Then take another hook and hook the top of the spring as a hold. Holding the top hook, pull the spring until the top glass slide pulls free from the bottom slide. Then measure the distance the spring moves with the ruler. I measured the bottom glass slide to be 0.07574 meters by 0.0252 meters, and the top glass slide to be 0.07582 meters by 0.02522 meters. I measured the spring constant to be 142.2 newtons per meter. In the experiment, the change in spring distance for water, isopropyl, and olive oil was 0.053, 0.045, 0.075 meters respectively. Using the measurements I obtained from the experiment and water surface tension of 0.072 newtons per meter, I measured water's meniscus height to be 36.54 micrometers. For isopropyl alcohol, I used 0.022 newtons per meter as isopropyl's surface tension. Using the same equation, I calculated the height of meniscus for isopropyl to be 13.15 micrometers. Finally, for olive oil, I used the same equation but used olive oil surface tension of 0.032 newtons per meter to calculate a height of 11.47 micrometers. In conclusion, I calculated the height of meniscus for water, isopropyl alcohol, and oil to be 36.54 micrometers, 13.15 micrometers, and 11.47 micrometers respectively. Note that the isopropyl surface tension used in the calculation was for pure isopropyl alcohol. The isopropyl alcohol used in the experiment will have a slightly higher surface tension than the pure isopropyl alcohol. because the experimental isopropyl used was 91% isopropyl and 9% water. This could be the reason why isopropyl had a calculated height higher than olive oil. The values calculated for the height make sense since water had the highest surface tension and olive oil, by deduction, would have the lowest surface tension. Some errors in this experiment include measurements in the distance the spring traveled. Also, I assumed total wetting, which could have some errors since it can't be measured in this setup. Another error was that the top glass slide was sliding a bit when trying to pull up on the spring.